one of the topic that would come very relevant for us would be straight lines. Straight lines. And this is covered in the section named as coordinate geometry. So we would be restricting ourselves to two dimension as of now. So this will be covered under 2D or 2D coordinate geometry. Now, when we talk about straight lines, there are various formats of equation of a straight line, and one of the most common format that we see across various problems in physics as well as financial mathematics is the slope intercept form. Today we will be talking about this form of equation of a straight line, and we would see what are the various information that we can derive from this format of equation of a straight line, slope intercept form. Now, let's first try to catch the two words that are there in this form, slope and intercept. So the first part is slope, the second part is intercept. Let's try and look at the format of this type of equation. It's given by y equal to mx plus c. Now, the first part being slope and the second part being intercept must be there within this equation. Their information must be there within this format of equation. So we look at the equation and try to trace out these two parameters. So m stands for the slope of the line, and c stands for the y-intercept. While we have some primitive knowledge about what is slope all about, the intercept is something that is new that has come across in this discussion. So we need to first understand what is intercept, or more precisely, what is the y-intercept. Let us have a Cartesian coordinate system, and let me name this as x dash o x, y o y dash, and let me take a straight line, right, and try to focus myself on the point at which my straight line intersects with the y-axis, that is this particular point. Let me say that the straight line represents my equation y equal to mx plus c. I'm now trying to talk about the y-intercept. Now, let's try and analyze the length of the y-axis from origin till this point. So I would focus from here till the origin. So this is this. So I would say this is my y-intercept. Now, how do I quantify this y-intercept? The most interesting thing is this point on y-axis is nothing but c. So the length of the y-intercept is c, and the coordinate of this particular point would be 0c. I hope you understand that, right? So when you spot any equation which can be reduced in the form of y equal to mx plus c, try to find out what is the value of c. Once you find the value of c, you know where this line is going to intersect the y-axis. Okay, let's take an example, and let's say we have equation y equal to 2x plus 3, and the question comes to you, plot the graph or plot the straight line y equal to 2x plus 3. One of the ways to proceed to this problem would be the way we have been taught in our junior level classes, where we make a matrix of this order, right, and do iterations based on the dependent and the independent variable. We plot x here and we say y is equal to 2x plus 3, and you can take various iteration 1, 2, 3 and 4. You take various points and you try to find out what are the points on y. So you get various combinations of x and y and try to plot those on a graph sheet, and you get your line. Now how to do this in a much more simpler way? Now if you see this particular line, all I need to draw this line is basically 2 points. Let me call these points as point P1 and P2. I just need 2 points. Once I have 2 points, I can draw a straight line. So if you look back into what we just saw, one of the point can be very easily understood by just looking at the equation of the straight line y equal to mx plus c and comparing this value, that is in this case c is equal to 3. So we know this point is known to us. This point would be 0, 3. We just need the other point, and once we have the other point, we can easily say so we can easily plot our graph. Now how do we get the other point? That's where the slope will come into picture. Let's see that very quickly. Okay, how quickly we can do this. So let's draw a Cartesian coordinate system, and let's name the system now. X axis of the system x dash o x, y o y dash, and we are trying to plot y equal to 2x plus 3. So we first of all try to find out where is the point 3. So that's the point 3. So the coordinate of this point would be 0, 3, right? 0, 3. So let's say this is our P1. Now we want to find out where is P2. Now, once we find P1, our job will be to place ourselves here and try to play the card of slope. So what is slope? Slope is equal to rise over run. And when we compare our equation, we find that the value of slope here is 2. M is equal to 2. So we say M is equal to slope is equal to rise over run equal to 2, and 2 can be read as 2 upon 1, which means I have a rise of positive 2 and I have a run of positive 1. Okay, and since I'm doing the slope of a straight line, from wherever I try to plot the slope, it will be always same, right? Maybe you didn't get what I tried to say. Okay, let's look at this line, right? This is the positive direction of x-axis. This is the positive direction of x-axis. Now a straight line has a constant slope. What do I mean by that? The angle here is also theta. The angle here is also theta. That means the slope is m equal to, m is also known as tan of theta. So if theta is same throughout, so m tan theta is also same. The slope is also same. So I position myself out here, and my first job would be to rise. To rise how much? I would be rising 2. So let's say I start rising from here. My rise is equal to 2. So if I rise from here, this point being 3, I rise 1, that's 4, and I rise 1 more, I've come to 5. Okay, on y-axis I've come 5, and my next job would be to run, and I'm running on the right side because my run is a positive entity, right? And the run is given by 1. So if I come to 1, I have exactly come somewhere here. Okay, let's say I've come somewhere here, and on x-axis that particular point would be 1. That particular point would be 1. So what is the coordinate of this point, which is my required point, which would be my P2? My P2 is 1 stroke 5, right? All I now need to do is take my ruler and try to join these two line points and draw my line. That's it. So I'm done. This is my equation of line y equal to 2x plus 3. And I can have an iterative check. You can see out here, if you take x equal to 0, you get 2 times 0 is 0 plus 3, 3. So 0, 3 is point is correct. And if you take x is equal to 1, 2 times 1 is 2 plus 3 equal to 5. So 1, 5 is also a correct point. How easy it becomes. So next time you are given an equation, let's say I'll make it a little bit more complex. And okay, before that, let's find one more thing. Y equal to 2x plus 3 was our equation, 2x plus 3. So if you look at the slope, m, which is equal to 2, the slope is positive, right? Therefore, the theta should be acute. And if you try to look at theta, theta is acute. This is acute. Wow, it solves everything. It's acute. And theta is always, if you have forgotten, it is angle between line and positive direction of x-axis, right? So what if the equation is not given in this format, and somebody says the equation of the straight line is given in this format, say 2x plus 3y equals to 5. So what I do, I convert this equation, that's 3y is negative 2x plus 5, or y is equal to negative 2 upon 3x plus 5 upon 3. The information that I have, straight away I need 2 points. So my first point P1 would be the y-intercept, which is 0c. So I compare it with y equal to mx plus c. So the first point would be, my first point would be 0, 5 over 3. And my next point would be determined by the slope, which is equal to negative 2 upon 3, which means my rise would be negative 2 and my run would be positive 3. And this being a negative slope, it will make an obtuse angle. So let us try and see that also. Let's tweak our first equation and make it from y equal to, we had 2x plus 3. We tweak our equation and make it y equal to negative of 2x plus 3. Now, if we compare this, y is equal to mx plus c, we would say c is equal to 3, m is equal to -2. That means slope is negative, which means theta should be obtuse. Right? Let's plot and see whether our understanding is correct or not. So let's take a Cartesian coordinate system. Right? Everything remains the same as before, x dash o x, and this is y o y dash. The first point P1 would be 0, 3. So this is my point P1, and this point is 0, 3. Now all I have to do is I have to go by my rise and run. So let's see what is our slopes. Let's see what's our slope. Slope m is equal to -2 is equal to rise, pardon me, is equal to rise over run. Rise being -2, run being +1. So this time I would rise -2. So let's rise -2. That's out here. So if I come -2 on this side, that means 3, 2, 1. So I have come at 1, and after that I would be running +1. So that's +1. So the point at which I would come down is this. The point is this, and this would be my point P2, and the coordinate of this would be 1, 1, because I've come down to 1, and this is also 1. So all that I need is now to join these two points. And how interesting. Just look at the angle now, theta. That's obtuse. That means slope is negative. So given any equation of a straight line, the summary says bring the equation in the format of y equal to mx plus c, have a look at m, that would be your slope, have a look at c, that would be your y-intercept, right? And the point at which this particular line would cut the y-axis would always be 0c. Position yourself at 0c, and after that follow m, which is rise over run. If you have a positive rise, go upwards. If you have a positive run, go rightwards. If you have the opposite case, that's a negative rise, go downwards. If you have a negative run, then go to the leftwards. So going further, some of the more interesting things that we get to know from here is let's again draw a Cartesian coordinate system. Now this thing is getting interesting. So what we have discussed so far, we took two equations. One is y is equal to 2x plus 3, and we took y is equal to negative of 2x plus 3. Now when we had a look at y equal to 2x plus 3, our line was making an acute angle, and when we took minus 2x plus 3, our line was making a obtuse angle. When I say acute and obtuse, I need to also show you the positive direction of x-axis. So that's the positive direction of x-axis. So if you look at both the cases, so far we have discussed, this is theta acute, and here theta is obtuse. Now let's take an interesting case. Okay, x dash o x, and let's say y o y dash. Now I take an equation y is equal to 4. Y is equal to 4. Now all of us know that the equation of the x-axis, right? The equation of the x-axis is given by y equal to 0. So when I say y equal to 4, I'm basically trying to draw a line which is just offset by positive 4 from the origin on the top side. So how will it look like? It would look like something like this. It would look like something like this. This is y equal to 4. Y equal to 0 is the x-axis. So this is y equals to 4, and if I concentrate on this particular point, the coordinate of this point would be 0, 4. Now, how is this line? Let's try to draw a positive direction of x-axis with this line. Now, this is the positive direction of x-axis, and if I try to trace theta now, I would say theta is equal to 0 degree, which means slope is equal to 0. Now, how do we marry this with the concept we studied so far? Well, we studied y equal to mx plus c. Now, bring down your equation y equal to 0x plus 4. That's exactly this equation written. So, once again, c is equal to 4 and m is equal to 0. Slope is equal to 0. Right? Isn't it interesting? looking at the line, you can see. So we covered all these three sections, how to see a positive slope. So given any line, say suppose somebody tries to give us a question and the line is shown in this manner. Many children get confused saying that what about if the line is shown in this manner? The line is shown in this manner. Fourth quadrant, irrespective, wherever it is. All I need to draw a positive direction of x-axis with this line and look at the angle theta. Theta is acute. So you say this line will have a equation y equal to sum m x. Now comes the question of y-intercept. Should it be plus c? No, it should be minus c. Why? Because it cuts the y-axis on the negative side, and I would say that this particular point now would be 0, negative c. So the y-intercept is negative. Y equal to mx minus c. Any line in this format, the equation would be y equal to mx minus c. Let's take one more example. Okay, let's take one more example to reinforce our lining. So this is a Cartesian coordinate system, and somebody tells us that the line is drawn in this way. Comment on the slope. Well, it's very simple. We go by our basics. We'll first draw a positive direction of x-axis. So this is the positive direction of x-axis. First look at theta. Theta is obtuse. That means the slope is negative. So what should be the equation of this line? Y equal to negative mx. Now talk about the y-intercept. Well, the y-intercept is also on the negative side. So this point would be 0, negative c, right? So it would be y equal to negative mx, negative c. I hope by now the conceptual understanding of slope and the equation of straight line in the slope intercept form of y equal to mx plus c under various scenarios. So next time you see a line, you need not do any sort of iterations. Look at the line, look at the way it is inclined along with the x-axis, look at where the line tries to. All you need to do is two things. Okay, number one, you need to look at theta, and number two, where does the line cut the y? You can hear some better English out here, which is known as intersect the y-axis. And for this you can have only two solutions. It can be either a 0c or it can be a 0, negative c, based on that former equation. Look at theta. Based on theta you can have m can be equal to 0, m can be plus m, or m can be negative m. So these are the type of equations that you can iterate out by looking at the graph itself. Let's take a small example. Suppose we want to organize a birthday party, okay, and we need to arrange for food. So we order a caterer for our food requirement. So we go to a caterer, and the caterer gives us a quote saying that he would charge us rupees 800 per person, okay, per person, and he would also charge rupees, say, 1,500 towards his transportation, okay, towards his transportation. So now I'm from India, so the rupees comes much more easier to me. You can take the currency of your country, but the scenario remains the same. So the scenario is that I have a birthday party and I need to arrange for food. I approach a caterer, and the caterer says that they're going to charge me 800 rupees per person and rupees 1,500 for transportation. Now look at the scenario. Now if I try to work out y as my dependent variable, which is the amount payable by me, that would be equal to 800 times the number of person, where x is the number of persons or the guest who will consume food, and I need to pay 1,500 towards transportation. Wow. Bring it back to our Cartesian coordinate system and slope intercept form, y equal to mx plus c. So if you see this graph, okay, what do we infer from here in terms of financial mathematics? Say suppose no guest turned up for our birthday party, but the caterer came. I have to still pay him 1,500 rupees. So if I try to plot the graph and bring a little bit of taste of financial mathematics out here. So we won't have a negative side because number of persons cannot be negative. So what is the value of C in this equation? Let's see the value of C first. Okay, let's see what's the value of C. C is 1500. That means the first point that I plot is 1500. Now look at the beauty part of this. Now, irrespective of how many people attend my birthday party, 1500 I have to shell out. I have to shell out 1500 rupees to the caterer towards the transportation. So this part I have to pay. Financial mathematics, I would call this as my fixed cost. And thereafter, I start paying based on what? Based on the number of people that attend my birthday party. So the graph goes in this manner. All right, where on the x-axis I would have number of people, right? And say only 10 people attended my birthday party, right? It rained very heavily, people didn't turn up for my birthday party, and only 10 people attended my birthday party. So let's drop it down at 10. So let's drop it down at 10. So if I look at the analytical solution, it would be 800 times multiplied by 10 plus 1500, right? So this part is my variable cost. This depends upon how many people have attended my birthday party, and this is my fixed cost. So in financial mathematics, all I will arrive is total cost is equal to variable cost plus fixed cost. Many of you might have learned this as a part of preliminary economics concept. So the same thing comes up. So this would be this is my variable cost, right? This is variable cost. And if I try to look at the entire portion, that is the green shaded part, then this is my total cost, which is equal to fixed cost plus variable cost. Trust you have understood now what is the slope intercept form and how to interpret the slope of a straight line, or given the equation of a straight line, how we can convert it into the slope intercept form and plot its graph and draw various inferences.